Okay, so this is lab 9 in the natural language processing with Orange book, and this lab is on text classification. Okay. This correlates with chapter, this is the main textbook. So in the main textbook, there is the like informational stuff. So chapter 7 is text classification, the last chapter in the main textbook. Okay. Now, all of the materials are on dataanalyticscurriculum.com. This is the data I'm going to use. It's a free download. And then this is the lab book that we're following, the Orange lab book. So text classification literally is that. It's taking text data and classifying it into categories. An example of this would be spam filtering, which is actually the example we're going to use. The machine learning based sentiment analysis really does follow exactly this protocol as well, except this is more generic than just looking at sentiment analysis. Classification has to have labeled text, meaning that there has to be in the data some type of categorical variable like spam and not spam, positive and negative sentiment. So you have to have a label column in the data to base your classification on when you build your model. Now, once your model is built, you can use it to classify novel data, which is kind of the whole point. But in order to actually build the model and build the initial classifier, you must have labeled data. Okay. So you have to have categorical or labeled data. So this is in fact a method of machine learning. Spam filtering is a good example. Yeah, pretty much everybody these days has an email filter that will literally filter out half the email from your students. Oops, as spam. Sentiment detection, positive, negative, those are really popular ones. Topic labeling of other things, important, unimportant, maybe something like that. The data is encoded, it's turned into numbers. And so this lab sort of builds on lab 1, lab 2, lab 3. Um, it's not, you don't really need the sentiment analysis stuff for this, but you do kind of need the first 4 labs. So there is like a little build on here. It's also helpful to have a little bit of a background in data mining. All of my data mining videos are still up from the old course. I'm going to redo that with the new books, either for my upcoming course that starts in a couple weeks or just in general, like I'm doing here. Okay, so this again is the book. It's available on dataanalyticscurriculum.com. It's also available on Amazon in print copies. Yeah. So the algorithm we're going to use here for our classification is naive Bayes, which is just a build on the probability theorem Bayes theorem that most people are familiar with from intro stats. The other ones, like you can use logistic regression and other classifying methods. I did use logistic regression in lab 6, I believe it was, when I did the sentiment analysis machine learning methodology. So there's different algorithms for classification. Basically, classification is it's a build on your sort of basic regression model where your outcome is not a continuous variable, but some type of category. And essentially, these classifier models build not just necessarily one variable, they essentially build a regression model with coefficients. And then you build the model, you test how good the model is, and you can use it for future classifications when you have unlabeled novel data, which is kind of the whole point. So this algorithm, when you do it on text, it assumes that words contribute independently. In other words, they're not linked and it doesn't consider context. So it's a relatively simplistic algorithm, and it works well in practice. Okay. So we're going to use Orange to build and test a naive Bayes classifier based on text data. Okay. So I'm going to go back and forth between Orange and the slides explain and then Orange we do. So the first thing we're going to do is load data and create a new project. And the data we're going to use is called spam.csv. That is in this data file here, right in here. And it's free to download, so you have the data if you want it. Okay. We're going to use the columns within this data. We're going to use our message, and then we're going to use label as category. Okay. Okay. So this is what it's going to look like in Orange. We're going to use a file widget and then upload the spam data. And then we're going to select the target variable with the select columns widget. And the target variable is called label, which is whether or not it's spam or not. And that's going to get hooked up to the file widget. And then we're going to do select columns, and target label is going to be very important. And then we're going to create a corpus because we are working with text data, and we do want to be able to use this is so that we can use the text mining features, including encoding the data and preprocessing the data. So we're going to select the source to message, and then we can look at it in the corpus viewer. So let's go ahead and do this because I don't like doing too much at once. Okay, so I'm in Orange, and I'm going to open a new workflow. And then I'm going to add the file widget from the data menu and upload my data, which is spam.csv. And hit go to reload. Okay. Next, I'm going to connect this to a select columns widget, which is under transform. This is important to essentially what this is going to do is it's just going to make sure that we have like the Y output variable set. So the target variable is going to be label. So you want to make sure that you move that down here. And I have to like move it around here and then down here. And again, move it here. We're good. Okay. And hit go. Next, what I want to do is I want to actually create a corpus. So I'm going to flow this through a corpus widget. And that's because I'm doing text analytics and I'm going to be doing encoding and stuff here. So these widgets, their input has to be in corpus form, most of them. So I run this into a corpus. Now we can always look at a corpus with our corpus viewer, which I almost always do. And you see this is what we have. So we have our labeled data, spam and ham. Win a brand new car, so this is spam. Again, it's just a toy data set made up. Has 30 rows. Okay. And they're all labeled as spam or ham. So this is the data that we're working with. Okay. Ham means not spam, not the food. Okay. And try not to stretch things too weirdly because you'll get things that are like off the page, but that should be okay. I think we're okay. All right. So we have Orange set up, and our corpus is ready to work with. Okay. Next, let's go back to the slides. Okay. So now that we have this set up, we're going to pre-process our text. This is lab 2, which I keep emphasizing is sort of an important lab. Lab 1 is setting up Orange, so you can kind of figure that one out. Lab 2 explains what pre-processing is and how to go through it. So the general 3 steps in pre-processing are lowercasing, tokenizing, and removing stopwords. Okay. Okay. Now, unlike other tasks that we've done, we actually want to filter this a little bit and not necessarily keep everything. Because we're doing modeling, we want to just only keep like the most popular words. We don't necessarily want to keep the most popular tokenized words after pre-processing. So we don't necessarily want to keep words that just have like a frequency of 1. We want to keep like more predominant words because we are making prediction models, and you don't necessarily want to have every single word in there. So we're going to actually do a little bit of filtering here. Okay. And we're only going to keep the top 100 most frequent words and filter out ones that are not as common. Okay. So that's something a little new. So the pre-process widget we're going to add, we're going to do the lowercasing, the tokenization, the stop word filtering, and also we are going to add a frequency of keeping only words that appear between 10% and 90%, not everything. Okay. And we're also going to add this and just keep nouns and verbs. Now, typically when you're tokenizing and pre-processing, most of what you keep after removing stop words is going to be nouns and verbs, but we are going to check that off as an added filter. Okay. After we do our pre-processing, we're going to do our encoding. This is lab 4. And this is when I talk about like how we go from having verbal tokens to encoded numeric text. And then the computer is really working with the numbers. It specifically is working with number vectors. They get kind of complicated and I can't totally explain them, but the computers are always working with numbers. So you're always taking your text data and every letter has a numeric code and it's figuring out like the codes for the words and then codes everything. And you're essentially, you have these like word vectors and you're mathematically working with them and you make your model. So, yeah. And we're going to use TF-IDF, which is explained in Lab 4, which is one of the ways to encode. What TF-IDF does is it doesn't just consider word frequency, but it also considers like the relative times the words are used in each document. In this case, there's 30 lines, 30 documents. Okay. So this is what our sort of final chain is going to look like. Upload the data, set the target variable, make it a corpus, pre-process it, and then we're going to use TF-IDF with bag of words. Okay, so let's go in Orange and set this up. Okay, so I'm back in Orange. My data gets uploaded in files, select columns, corpus, that we did before. Next, I want to add my pre-processed text widget from the text mining menu. And I'm going to flow my data into here and then click on it. But I'm going to tokenize and filter, but I'm also going to do this document frequency. And this will sort of eliminate really uncommon words or like 100% words. And then also check off POS is part of speech and only include nouns and verbs. Okay. So yeah, so I'm going to do that. So a little filtering just so that really rare or really, really common tokens aren't kept in. Okay. So that's the pre-processing step. And most of the time I look at this with a corpus viewer just because I'm always paranoid that it's not working or something like that. But okay. So corpus viewers don't do anything except view the corpus. So just click on this. And it looks good. Are we still meeting today? I guess those are all and So you'll see that there's not like it's not including as much as it did before. Actually something doesn't look right. Like it's not including enough stuff. This should have more. Actually, I'm glad I looked at this because it doesn't look right. Hang on. Let's go back here and let's use this instead. Let's see what this looks like now. Yes, this looks better. I made it too restrictive. So what I'm doing is keeping the top 100 words in terms of frequency. So this looks better. Okay. So notice that like some of the words are kept and not all. Congratulations, you qualify for a free upgrade. So like everything's lowercase. Words like you are filtered out. Those are our stop words, but also some other words will be filtered out too. Like last is filtered out. That may or may not be a stop word. So now we have sort of like our essential tokens. And then so this is like filtered down and this is what we're actually going to use to make our model. So it's effectively taking like the pool of words. It's going to make a classification model and the pool of words that are associated with ham are going to be distinguished from the pool of words that are associated with spam. Ham is not spam, and spam means spam. Ham is just their word for not spam, which I've seen in other cases too. I would just do spam and not spam, but they used ham. So this is how the data is now set up. It's pre-processed, it's tokenized, it's filtered out a little bit, and this is ready to actually use. Okay. Next thing we can do is encode it. We do want to encode it because we are doing like mathematics on words when we're making a prediction model essentially. So that is a mathematical entity and we want to make sure that it's encoded. So we're going to add our bag of words and we're going to hook that up to our data. And we're going to make sure it's set to document frequency IDF. If it's set to none, it will do the basic bag of words. Bag of words is not the same thing as TF-IDF, but they do use the same widget called bag of words. So we change it to the IDF and leave it like that. Now, again, I could look at this with, no, this I don't want to look at with a corpus viewer. This I want to look at with a data table. This step is not necessary, but I usually do it anyways. Okay, so data table, and click on it. And you can see that the words have numbers associated with them. So here are your like numeric encodings of your words. The book actually talks about how exactly these are calculated. A lot of them look to be 3.401, but not all of them. So that's kind of interesting. That means the ones that have the same, they have the same frequency, which is why they have the same number on them. So, okay, that should work. We should be okay. I'm kind of winging it, but anyways. Okay, so that's all set up. Everything's encoded. It looked at it with a data table. And now what I want to do is go back to the slides. Okay, so this should be all good. I looked at it. Now what we're going to do is we're going to do our kind of like machine learning stuff. So we have the data, and we're going to split it into a training and a testing subset of the data that we have. So this is all of our labeled data. Okay. And I'm going to do a 70-30 split because it's a small data set. I do an 80-20 on a bigger data set, but I just want to make sure that I have a reasonable number in test. This is what we're going to do to make the model, which is going to be a naive Bayes. I think it's called naive, I don't know. And then this is the one that we're going to use. We're going to make the model based on this. This we're going to feed into the model to look at whether or not the model's working and classifying things effectively. Okay. We're not yet like using novel data. We're using this data, which is why you use the test set, because you want to have those labels in the test set already there. And you want to verify, what you're going to do is verify that the labels that are already there are being predicted by the model created in the training, because you want to make sure that the model's working. Okay. And to do that, we're going to set it up. Now that you have to be super careful about how you set these up. So we're going to flow our data to a data sampler. And then we're going to set like the proportion of data. This becomes the training data. Okay. And then what we're going to do is we're going to be careful about how we connect things. We're going to use a naive Bayes widget. That's going to be our modeler. And we're going to flow the training data through this. And then we're also going to flow the remainder of the data to a tested score widget, which will evaluate it. And it's going to look like this when we set it up. This is our data sampler. This is our training data. And make sure that you pay attention to how the connectors are labeled. That's the things connecting the widgets, because you can click on them and check off what's being sent. And you have to be really careful that you're sending the training data, which is called sample data in orange, to the model widget. And then you're sending the test data, which is the remaining data, to just the test and score, not through the model, because you don't want to be creating your model with your testing data. And then the test and score widget will do the evaluation. So let's go in orange and do this. Okay, so I'm in orange once again, and I'm going to go flow my data through my bag of words. Okay. And do my sampler. Now the sampler widget is under, I can never find it. It's under transform, which is not where I would really expect it to be. Okay, so under this sampler widget, now set it to 70% right here, and then always hit sample data. Okay. So we've sampled, Then we want to hook it up to our model, which is going to be a naive Bayes, which is going to be down here under model. That will hook that up. Now on here, make sure this is data sample. That's the data that's being sent because you can send it the remaining data. This is the training data and the test data. You only want to send the training data to the modeler. Okay. And then we're going to also do a test and score widget here and send the model to the test and score widget. So we send the model in, but we also want to send the remaining data into this. But this time, see, this is what I'm talking about. You don't want to, now you want to send your sample data, your training data to your model, but you want to send the remainder to the test and score, not that. So you need to change that. Now it's correct. Even though it's complaining, it's okay, don't worry. Yeah. And then this is going to tell us how well our model ran with metrics. Now these metrics, they're not as friendly to look at as looking at the confusion matrix. So, and every time I run, like they don't really come out super well. The overall accuracy is 44%. This is just one sample though. Okay. And it's basically just warning me that I have a really small sample. That's why it has a warning on it. I'd rather look at a confusion matrix. So I get that in the same place under evaluate. And the confusion matrix is just easy to interpret. So I'm going to run it through a confusion matrix. Now for this sample, it didn't do super well. Okay. However, I know from looking at this that my model is running just fine. It's not a model issue. It's just that it's just not a really good sample in terms of how it's performing. So what you want is for ham to be predicted as ham and spam to be predicted as ham. Now this guy, it didn't do very well because we only have 4 of them that are accurate and then the others are not. So we have five misclassifications and 4 correct classifications, which is not really what you want to see. But that's just one particular sample. So you can go back into data sampler and resample it. And you'll get a different result every time you rerun it. So this one actually did exactly as bad as the other one. Again, 4 of them are correctly sampled. So let's see if we can just roll the dice and do a little better. So sample again. And then I get the same oh no, this one did a little bit better. It got 5 right. But ideally you'd like to see nothing misclassified, but that doesn't happen very often. And this is just random like data, so I didn't like fix anything. I'm gonna keep doing it till I get one that I like. They keep coming out like that. I don't know. Okay. They keep being like the same ones, which they shouldn't be. Although this one is a better accuracy. This one has 55%. So 5 out of 9 were correctly classified. I should be seeing some though that are in the spam. So this, I don't know what the frequency of ham and spam are, but I keep getting like hardly any of them to be predicted spam, which makes me wonder that the model seems a little biased. It's not a good model, but that wasn't really the point. The point is to actually make the model. I'd really like to see a different result. Let's see. Okay, so it is working. This is actually a pretty good one. So this one got 7. These are the actual, this is the label from the data. 5 hams got predicted to be ham. 2 spams did get predicted to be ham, but 2 spams got predicted to be spam. So the overall accuracy of this is 7 out of 9 correctly classified. I mean, I kind of cheated and ran through a bunch of bad samples, but 7 out of 9 is probably not too bad. So if you every time you resample, because you're going to resample, you're going to get a different result. Okay. For some reason, I keep getting the 5 and 4 results. But that's not really the point. The point is that we can make, we're taking text data. So we enter our text data. We have a target of the label, which is ham or spam. We're making a corpus because we're doing text analytics with it. We're doing our pre-processing. So we're stripping out our our stop words. We're stripping out sort of like not really that relevant words. We're making everything lowercase. Then we're coding it. We're turning our text data into numeric codes with the TF-IDF algorithm. Then we are doing our sampling split. So 70% of the data is being used to make the model, and then 30% of it's being used to test the model. And what we're looking at in this test and score is how accurate the test data. So 30% of 30 is 9. That's why you have 9 samples in here. And so every time we run this, you can actually see down here like 30 and then 21, 9. This is how it's being split. Let's try it again. I like doing this. It's just fun. But I seem to be getting I seem to be getting sort of a bias. Um, so I would look at this further, but it's not, this is only a really small like demo data set, so it's not perfect. Okay, but this is in fact a way to do text classification and then look at how accurate the classification is doing. The point here is that now that you have the model built, you can take you can take stuff that doesn't have labels and you can use this classification model and it will produce whether or not it's spam or ham. So you can take new stuff and it's going to make a predictor which you can obviously use to categorize things, which is the whole point. So that's what text classification is all about. Okay. So to wrap things up, the accuracy when I did the one that I made the slides with was 57%, but that seems to be about sort of the best that it gets. The confusion matrix gives your detailed, it gives your misclassifications and overall classifications. I did a slightly different split in this one. I don't know exactly what I did, but this one didn't have as much data, I don't think. This one was only on 25 and then 18, 17. I think I actually used a different data set in this one with the same, it was also a spam data set. So every time you run, you're doing your modeling based on sampling. The split is a sample, 70%, 30% is a random sample in each. Without replacements because they're mutually exclusive. You don't want to have the same data in the model builder and the model tester. But this is how it would work. Ideally, you get like a much better classification accuracy, but you might not. It's better than 50% though, so it is actually an improvement over random assignment. Um, Ideally you want to have better than that, but you have to work and make a better model in order to do that. So you might fiddle with like how you're doing your encoding, you might fiddle with like how you're filtering your words out or something like that and like improve your model. I'm not going to for the purpose of this because the purpose is to demonstrate the technique. So this involved building a simple text classification pipeline with the naive Bayes algorithm. There are other algorithms, so like for various reasons, you might want to try another algorithm if you don't get great results. Loading the data, pre-processing the data, encoding the data with TF-IDF, and then running the model with training and testing data, and evaluating its accuracy. The models weren't great here, but they were better than randomly assigning things. So I guess that's an issue. But you should learn how to like evaluate models. The data mining course specifically actually teaches a lot more detail about like evaluating models with different methods and what those metrics mean. But for this purpose, this does introduce how to do a text classification model for natural language processing, which you can see like this would be something very helpful to have a good way to take text data like emails and then work with those emails, process the text in them, and have a determining classifier as to whether or not they're spam or not to filter them out. And we all know that in reality, at least my email filters don't work very well. But they do work. I mean, there is some validity to this, and this isn't one example of how to do text classification. Again, all of the materials and stuff are in here. The data that I use is available here. Book is here. And I hope this is helpful because it's good stuff. All right, thanks.